Hey guys, I want to talk about volume. Um, and we're going to start out talking about volume by defining exactly what it is. So, volume is a measure of how much stuff is inside something or how much stuff could be in something. Volume is the amount of space something takes up. So, for example, I have a jar of peanut butter right here. And a volume question could be how much peanut butter is in this jar? Or how much Gatorade is in this bottle of Gatorade? So volume's all about how much stuff is inside something. And that stuff can be anything. Now, one of the ways that we measure volume is by using this. This is a unit cube. And we call it a unit cube because, well, every side is exactly the same length, or it could be one. Okay. So we could imagine in this case, each side of the cube is 1 centimeter. And so this would be 1 cubic centimeter. Now we can figure out how much volume is inside something or how much space something takes up by using these little cubes. So, one of the first types of problems that you might come across is taking a look at these wonderful types of shapes here. So, these are objects that have been made up of unit cubes. And to find the volume, you simply have to count how many cubes are in the structure or the object. But you have to be careful to recognize that these are three-dimensional cubes. So, the pictures are trying to show you that. So, if I look at this purple object here, I can count. Oops. Let's make that a little smaller there. I can count how many cubes are in this whole thing. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 cubes there. So the volume would be 9 cubic units. And that's very important that we always express volume as cubic units. Another way I could have looked at this problem here is I have 3 rows of 3. And we know that 3 times 3 gives us 9. So a couple different ways to uh, determine the volume, 9 cubic units of this object here. So let's take a look at this green object. So this green object, again, we can count all the green cubes. So 1, 2, 3, oops, 4, 5, 6, 7, 8. And we see that the volume here is going to be 8 cubic units. But once again, there's another way that we can visualize this. So if I back up a little bit here, and I want to get rid of the numbers so it's really easy to see what I'm talking about here. If I look at this green object, I can think of it as actually 2 objects that have been put together. And there's a couple different places where I can see that happening. But I'm going to focus on this boundary right here. So imagine there's a boundary here. And so what I can actually do is I can consider this volume here as 2 cubic units. Try to fix that in there. And then I can consider this other object, and I see that this object has 6 cubic units. And I can add these two pieces together for a grand total of 8 cubic units. And this type of thinking is really going to come in handy when we talk about finding the volume of what are called compound figures or objects. Objects that are made up of 2 or more other objects. And then down here, we have an object that's very similar to the purple object up top here, but a little bit different than the green one. And that's because the purple and the orange object here are classified as rectangular prisms. They have 6 sides, if you consider them as one whole object. And you can kind of think of them as boxes. Um, so, once again, counting the unit cubes will give us the volume here. But I'm going to start thinking more in terms of like a multiplication problem or an array. So if I look here, I have 2 rows of 1, 2, 3, 4, 5. And so the multiplication problem that's going to help us here is going to find the total number of unit cubes is going to be 2 times 5, which gives us 10. And so the volume of this orange object is going to be 10 cubic units. And so that's kind of the introductory um, type problems that you come across when you first start learning about volume. Now, we talked about rectangular prisms, and here's a picture of one. And you notice it just looks like a box, and it has 6 faces or sides. So we have 1, 2, 3 sides or faces that we can see, but then we have to be able to understand that there's going to be a 4th side we can't see on the back here, a 5th side that we can't see that's going to be opposite of the second face here. And then, of course, there's a bottom side that it's sitting on. And actually, it has a special name called the base. And a good way to remember what the base of a 3D object is, like a rectangular prism, is base, bottom, both start with B. So we can find the volume of an object like this using this formula here. Length times width times height. And a lot of you guys are probably familiar with this part here, length times width, because in previous years you found the area of 2-dimensional objects like this, where you had a length and you had a width and you multiplied them together and it gave you the area. But now that we're dealing with 3-dimensional objects, we're adding that other dimension, that height, in there. And we're using that to help us find volume. So volume is length times width times height, but we can also think of volume as area, since that's what length times width really is, times height. Oops. I apologize, guys. My computer is lagging tonight a little bit on the drawing, unfortunately. So my writing is a little messier than normal. So let's go ahead and let's name some of these sides here and do some volume calculations. All right, so I'm going to zoom in here on our first rectangular prism, and you can see it kind of looks like a green shoebox. Okay, so let's go ahead and give each of these 3 dimensions, length, width, and height, um, some values here. So we'll write length in red here. And guys, usually when you see an object like this, usually this will be named, this side will be named the length. But it doesn't really matter whether this side or this side is named the length. Okay. But we'll name this side the length for the purposes of this video. So we'll say that the length here, or L for short, is, let's say, 3 meters. Okay. And now let's talk about the width. And the width is usually this side here that's shaded to make the object look three-dimensional. But again, it's not always. This side could be the length too. But we're gonna keep that side the width. And let's say that it has a length. It looks like it's a little longer than, or I'm sorry, let's say it has a width. It looks like it's a little longer than the length of 4 meters. And then the height, not surprisingly, is going to be the distance from the bottom to the top of the object. So let's say that the height, let's say that the height also has a measure of 3 meters. Okay, so what we're going to need to do in order to find the volume here is multiply our length, our width, and our height. So if I multiply my length and my width first, and remember, it doesn't matter which order you multiply your numbers in because of the commutative property. So it doesn't matter what numbers we multiply first. But I'm going to choose to multiply the length and the width first. And we know that 3 times 4 gives us 12. And since we're multiplying 3 meters by 4 meters, and remember that length times width is area, 3 times 4 is 12 meters squared. Okay. So now what we have to do is we have to multiply this answer here, 12 meters squared, by our height, 3 meters. So I'm going to multiply my 12 meters squared by my 3 meters. And let's see, 3 times 2 is 6. 3 times 1 is 3. And I get 36. But notice I have meters squared multiplied by a meter. And as you might have guessed, I'm going to express my volume or my answer here with a unit meters with a little 3 exponent above it. And the way we say this is 36 meters cubed, or 36 cubic meters. And remember, when we were talking about the unit cubes, we talked about how the volume is measured in cubic units. So let's take a look at one more example here. And I put this lighter green rectangular prism up on the top of my screen. Okay, so let's figure out where we're going to put the length. I'm going to choose to say the length of this rectangular prism is right here. And so the width of this rectangular prism will be here on this side. And then the height we'll put right there from the bottom to the top. And remember that a lot of times they'll have this shaded area as the width, but it doesn't really matter which side is length or width, okay? So let's go ahead and assign some values to each of these. Oh, and I forgot to write my height here. Let's go ahead and assign some values here. Let's say that the length, or L for short, is 1 inch. So this is going to be a smaller rectangular prism than our last one. Let's say the width is 4 inches. And then we'll make the height 2 inches. Okay, so our volume formula says we have to multiply all three of these values together. So writing the problem out as an expression, we're going to have length is 1 times width 4 times height 2. And using the order of operations, I'm going to evaluate the first multiplication problem here coming from the left, which is 1 times 2, or 4, sorry, 1 times 4. And then I'm going to bring down my times 2. And that's the last step in my expression here. And that's going to give me 8. Remember, we have units here, so we don't want to forget about our units. So this is 8 inches. And because this is a volume measurement, this is going to be 8 inches cubed, or 8 cubic inches. So I hope this helps you guys out on your first step in volume problems and assignments. The next video on volume, as I said earlier, we're going to talk about what's called compound figures, finding the volume of figures that are made up of more than one object. As always, guys, let me know if you have any questions. Thank you for watching.